Welcome back. Chapter 9 Hypothesis Testing. Section 9.1 Introduction to Statistical Tests. What are the focus points in this section? Understand the rationale for statistical tests. Identify the null and alternate hypotheses in a statistical test. Identify right-tailed, left-tailed, and two-tailed tests. Use a test statistic to compute a p-value. Recognize types of errors, level of significance, and power of a test. Understand the meaning and risks of rejecting or not rejecting the null hypothesis. Okay, we emphasize the fact that one of a statistician's most important jobs is to draw inferences about populations based on samples taken from the populations. Most statistical inference centers around the parameters of a population, often the mean or probability of success in a binomial trial. Now, methods of drawing inferences about parameters are of two types. Either we make decisions concerning the value of the parameter, or we actually estimate the value of the parameter. When we estimate the value or location of a parameter, we are using methods of estimation. Decisions concerning the value of a parameter are obtained by hypothesis testing, the topic we will study in this chapter. All right. Students often ask which method should be used on a particular problem. That is, should the parameter be estimated or should we test a hypothesis involving a parameter? The answer lies in the practical nature of the problem and the questions posed about it. Some people prefer to test theories concerning the parameters. Others prefer to express their inferences as estimates. Both estimation and hypothesis testing are found extensively in the literature of statistical applications. Stating hypotheses. Our first step is to establish a working hypothesis about a population parameter in question. This hypothesis is called the null hypothesis, denoted by the symbol H0. The value specified in the null hypothesis is often a historical value, a claim, or a production specification. For instance, if the average height of a professional male basketball player was 6.5 feet 10 years ago, we might use a null hypothesis H0 mu equals 6.5 feet for a study involving the average height of this year's professional male basketball players. If television networks claim that the average length of time devoted to commercials in a 60-minute program is 12 minutes, we use H0, mu is 12 minutes as our null hypothesis in a study regarding the average length of time devoted to commercials. Finally, if a repair shop claims that it should take an average of 25 minutes to install a new muffler on a passenger automobile, we would use H0 equals H0, that is the null hypothesis, is mu equals 25 minutes. As the null hypothesis for a study of how well the repair shop is conforming to specified average times for a muffler installation. Okay. Any hypothesis that differs from the null hypothesis is called an alternate hypothesis. An alternate hypothesis is constructed in such a way that it is the hypothesis to be accepted when the null hypothesis must be rejected. So notice you are going to accept the alternate hypothesis if the null hypothesis is to be rejected. The alternate hypothesis is denoted by the symbol H sub 1. For instance, if we believe the average height of professional male basketball players is taller than it was 10 years ago, we would use an alternate hypothesis H1, mu greater than 6.5 feet, and null hypothesis was H0, mu is equal 6.5 feet. You see, that's an alternate. If we reject H0, then we accept H1. So, what is null hypothesis? H0. This is the statement that is under investigation or being tested. Usually, the null hypothesis represents a statement of no effect or no difference, or put another way, things haven't changed. Whereas alternate hypothesis H1, this is the statement that you will adopt in a situation in which the evidence or data is so strong that you reject H0. Okay, you're rejecting H0. So this is the statement you will adopt. A statistical study is designed to assess the strength of the evidence, that is data, against the null hypothesis. So here we have an example. A car manufacturer advertises that its new subcompact models get 47 miles per gallon. Let mu be the mean of the mileage distribution for these cars. You assume that the manufacturer will not underrate the car, but you suspect that the mileage might be overrated. Okay, so what shall we use for H0? We want to see if the manufacturer's claim that mu is 47 miles per gallon can be rejected. Therefore, our null hypothesis is simply that mu equals 47 miles per gallon. We denote the null hypothesis as H0 is mu equals 47 miles per gallon. What shall we use for H1? From experience with this manufacturer, we have every reason to believe that the advertised mileage is too high. If mu is not 47 miles per gallon, we are sure it is less than 47 miles per gallon. Therefore, the alternate hypothesis is H1 mu less than 47 miles per gallon. All right. Now, types of tests, will come to these in our next videos. Until then, bye.